All right, guys, we're on the back side of Unit 5, Day 2 notes. And number 3 is talking about which of the following is not equivalent to x to the negative 7/3. All right, so let's take care of the negative exponent first. And hopefully you remember that all we have to do is make this go into the denominator of a fraction. Okay, and it's going to become a positive 7/3. Okay, so x to the positive 7/3. However, there's nobody holding him down there into the denominator, so we're going to have to make sure that the numerator gets replaced with a 1. Okay. So far, that is one of our choices, except we're looking for not equivalent, and this one is equivalent. Okay, so this is the same as the original. It's just that we took care of the negative exponent. Okay, so then the next thing that we can do is that we can replace the fractional exponent on the bottom with a radical. So we're going to keep the 1 over, but instead we're going to have a radical with the x underneath. Again, 3 is on the bottom, 3 goes into the crack because the bottom has a crack. Okay, and then your 7 will go on the x. All right, is that one of our choices? Yes, that's choice 2. And so this is also the same as the original. It's just rewritten instead of the fractional exponent. Okay, and I think you guys can pick your choice right now. We know that 7 was on the top and that the top number doesn't go in the crack. It's the bottom number that goes in the crack. And so I'm pretty sure that you guys can figure out that right now 3 is not the same. Okay. Number 4 is the same because the cube root of 1 on the top here is 1. Okay, so when you take the cube root of 1, you get 1. Okay, and then the cube root would stay on the bottom. All right, so just to show you guys why 4 is not our answer. Okay, it is the same as the original as well. Okay. All right, so in number 4 through 9, it says rewrite each expression into an equivalent radical form and then simplify if possible. All right, so one thing we have to be careful about, and the same thing we had to be careful about on day 1, is the use of parentheses versus the use of no parentheses. Okay, so watch out. All right, so in number 4, we are going to go ahead and draw our radical because we have a fractional exponent. 3a is grouped, and so we're going to go ahead and keep 3a grouped. Okay. The 2 is on the bottom, and so the 2 will go in the crack, and the 1 will go on the outside here on the 3a. All right. However, the 1 is not necessary to write, and neither is the 2 in the crack. And so you could write it like that, or you could also write it as just the square root of 3a. Okay. And again, the parentheses don't matter because you're raising both the 3 and the a to the first power. And 3 to the first power is 3, and a to the first power is a. And so that's why that's the same. Okay. So either one of those are good. Next one up, number 5. So we're going to go ahead and rewrite that fractional exponent. Okay. So we're going to use a radical. And notice the use of parentheses. Everything is grouped. So we're going to go ahead and group everything. So we'll group 81. A to the third, B to the fifth, all inside parentheses, just like it was in the original. 4 is on the bottom, so 4 will go in the crack, and then the 1 will go on the outside there of our parentheses. Right? And the only thing that we don't need here is that 1 on the outside of the parentheses, so we could rewrite this. Okay? We're keeping 4 in the crack. 81 to the first power is still 81. A to the third to the first power is still A to the third. And b to the fifth to the first power is still b to the fifth. Okay, and so we didn't really need the 1. Okay, the only other thing that we can do, and I'm not quite sure if you guys know this, but the 4th root of 81, and I believe we did it on the front of our notes, is a perfect 4th root. And so if you take your calculator, and you might be able to just look at the home screen. Yep, it's still in my home screen. The 4th root of 81 that we did on the front is 3. And so this becomes a 3. But because we took the 4th root of it, we took it out. We took the 4th root of 81. He's no longer going to be underneath the radical. Okay, but everything else still will be. So we still have a 4th root of a cubed b to the 5th. Okay, and there's our final answer. Okay. All right, and number 6. Okay. Notice no use of parentheses. So the only thing that the 2/3 is on is just the x. Okay, so the 125 is going to hang out in front. Then we're going to draw our radical. We're going to put x underneath it. 3's on the bottom, so 3 goes in the crack, and the square, or the 2, will go on the x there. Okay, and that is actually done. That was a nice simple one. Okay, I can't say that they're all going to be that simple. All right, next one up, number 7, we're back to using parentheses, and we have a negative exponent and a fractional exponent. I always like to take care of the negative first. So I'm going to go ahead and say this is going to go downstairs in a fraction. Okay? Notice it's all grouped in parentheses. So we're going to continue to group it in parentheses. Okay? The only thing I'm going to change is that this is now going to be a positive 5, 6. And I'm going to put a 1 on top to hold it down there. Okay? All right. What I'm going to do next is I am going to go ahead and change that 5, 6 to a radical. So I'm going to keep the 1 over. I'm going to go ahead and draw my radical. I'm going to group 4x underneath it in parentheses. Okay? I'm going to put 6 in the crack because it's on the bottom, and I'm going to put 5 here. All right. So using our properties of exponents, this could get a little bit messy, all right? But we're going to come over here, and I'm going to go ahead and keep the 1 on top. Okay? I'm going to go ahead and keep the radical 6 root on the bottom there. But from day 1, remember how we have bases in here too, and the number out on both of them, and we can distribute. So really, guys, this is going to be 4 to the 5th, x to the 5th. Okay, 4 to the 5th in your calculator is 1024, and then x to the 5th. Okay. And I don't know if you guys know this, but the 6th root of 1024 is actually a nice perfect number. So you could check it in your calculator. So again, if you hit your 6 key in your home screen, and then go back to math, go back to that general root button, which is number 5 under math, okay? And then type in 1024 underneath your 6th root. You're going to hit enter. Oh, nope, that one isn't perfect. I thought it was. All right, so never mind. So we can go ahead and ignore what I just said there. But it's good to check, because if you don't know, especially with a big number, you wouldn't know. So I'm going to go ahead and rewrite this, but we were finished at that step. Okay? So we're going to go back and we're going to say, okay, nope, we can't go any further. So we're going to keep the 1 over. We'll keep the 6th root. Okay. And 4 to the 5th, we'll keep it as 1024. We cannot take the 6th root of it. It does not come out pretty. Okay. And then we'll keep the x to the 5th under there. All right. And that is actually going to be our final answer. All right. So again, if you're not sure, you can always check in your calculator. You can make the same mistake I did, thinking that it was, and it wasn't. All right. Number 8. So again, it's actually very similar to number 7. You see that? All right, so the difference is there's no parentheses. So it's kind of like number 6. What they're trying to trick us on is that x is only raised to the negative 5, 6 exponent. So what's happened is that that's going to go downstairs, okay, and become x to the positive 5, 6. But the 4 is not grouped in the parentheses, raised to a negative exponent, so he's allowed to stay upstairs. So we don't need a 1 on top. We have the 4 to hold him down there. Okay? And then we're going to go ahead and rewrite that fractional exponent. So we're going to keep the 4 on top, and then on the bottom, we're going to have a radical. We're going to have x underneath there. 6 is going to go in the crack, and 5 is going to stay on the x. And you can see the difference between our two answers. Okay. All right, last one. Okay, so we're back to using parentheses. We have a negative exponent. Let's take care of that negative exponent first, okay? Everything is in parentheses, and all we're going to do is we're going to make everything go downstairs into the denominator. And when that happens, our negative 2/3 will become a positive 2/3, okay? Nothing on top to hold it down there, so we're going to need that 1 back again, okay? All right, next thing we're going to do is we're going to keep the 1 over. Okay. But we're going to rewrite that fractional exponent as a radical. Okay. 216a in parentheses still. Okay. 3's on the bottom, so 3 will go in the crack, and the 2 will stay on the 216a. Okay. We could go a step further with what we talked about from day one, that the 216 and the a are both grouped in the parentheses with the 2 on the outside. So that's really 216 raised to the second power and a to the second power. Okay. That can get a little messy, but I think we're going to be okay. Sorry, my phone keeps going up. Okay. So we're going to keep the 1 over. Okay. 216 raised to the second power. In our calculator is a really big number. Okay. So it's still underneath that cube root. And 216 raised to the second power is 46,656. And then we would have a squared. And before I make the mistake, I'm going to go ahead and check to see if that's a perfect cube. I would have no idea. However, I'm going to hit my math button. I'm going to go down to the cube root, which is number 4, and I'm going to put the number underneath there just in case. So 46656. All right, hit enter. It is. So in this one, it is. So this is a perfect cube. When you type it in your calculator, you end up with 36. Right? And so we're going to say our final answer is 1 over 36. And then that a squared is still underneath a cube root. So that was a really messy problem. Okay, that was a really, really challenge. I wouldn't worry too much about that one. As long as you understand the other ones, you're going to be fine. Okay. All right, let's take a look at the next one. Number 10. Now it says rewrite each expression into an equivalent form using rational exponents or fractional exponents. Okay, simplify as possible. So again, when they say rational exponents, they're indicating fractional exponents. Okay? A fraction is a rational number. Okay, so hopefully these aren't as bad. But in the very first one, we got to remember what number is in the crack when they don't write one. And hopefully you guys remember that that's a 2. Okay, so I'm going to put that 2 in there. So we're going to take the 5 and leave it. And then we're going to take the square root of x cubed, and we're going to write the x. Okay? And then remember that what's in the crack now goes on the bottom instead of what's on the bottom goes in the crack. All right, so the 3 is going to stay on top, and the 2 is going to go on the bottom. Okay, and I don't need parentheses because without parentheses, I'm saying that only the x is raised to that 3/2 power. Okay, because only the x was underneath the radical. All right, so that one's finished. Number 11. I'm going to go ahead and rewrite this. So this is going to be 1 over. That's 16x to the 5th. So we're going to go ahead and 16. Okay. So we're going to have 16x to the 5th. But it's all underneath the radical, so we're going to bring back our parentheses. Okay. And if you think about it, there's really a 1 here, and so that's going to be our 1/4 power. Okay. And then what we can do from day 1 is realize that that 1/4 power is not only on the 16, it's also on the x to the 5th. Okay. And so we're going to have 1 over 16 raised to the 1/4 power. If you check in your calculator, 16 raised to the 1/4 is the same thing as the 4th root of 16, and that's actually 2. And then here we're going to have x to the 5th raised to the 1/4, and so that would be x to the 5/4. Okay. And it didn't say anything about reversing and giving a negative exponent, but you could have. Okay. You could either have and leave that as your answer, or you could also say 2x to the negative 5/4 and get it out from being a fraction. Okay. Either one. Both of those are rational exponents. Whether it's a positive exponent or a negative, if it's a fraction, you're fine. Okay. Next one up, number 12. Okay. We're going to take that 27 x squared y to the 7th out from underneath the radical. Because it was all under the radical, we have to make sure it's all grouped. Okay. And if you think about it, there's a little 1 here. And so we're going to say that that's the 1/3 power. All right, so going back from day 1, we know that 27 is raised to the 1/3, x squared is going to be raised to the 1/3, and y to the 7th is going to be raised to the 1/3. If you check 27 raised to the 1/3 in your calculator, that's the same thing as the cube root of 27, and that's going to give you a 3. Okay, and then that's going to be x squared to the 1/3, so x to the 2/3, and then y to the 7/3. All right, last one is a little on the rough side, but let's give them a shot anyways. Okay. All right, so we got some parentheses with some other stuff. So we're going to take that a squared b to the 1/2 out from underneath the radical. But because it was all under the radical, we're going to have to make sure it's grouped in parentheses. Okay. Remember that there's a 2 in the crack, okay, and technically a 1 here. And so this is going to be raised to the 1/2. But then that's all raised to the -1. Ooh, this can kind of be a little ugly. Okay. All right, so then we're going to go ahead and say, well, we could multiply these two powers together to give us a little bit easier. And so we can say that this is the a squared b to the 1/2 in parentheses. And we're going to multiply these exponents because on an exponent raised to an exponent, you multiply them. So a half times a -1 is a -1/2. Okay. And then what we can do is we can go ahead and say from day 1 that a squared is going to get raised to the -1/2 and b to the 1/2 is going to get raised to the -1/2. So let's see what happens. When we multiply exponents raised to exponents, right? So we're going to have this 2 times this -1/2 is going to give us -1. Okay? And then we're going to have b to the 1/2 times -1/2, which is -1/4. Oops. Okay. And if we don't like negative exponents, although they are rational, we could leave it like that if we wanted to. Or we could get rid of the negative exponents as well. And we know that we can do that by putting 1 over. This would be a to the positive first, which we don't need the 1, and b to the 1/4. Or this answer is okay as well. All right, last question. These exponents can be exhausting. All right, it says, what does that equal? Whew, all right. Well, let's give it a shot. So we know that 2/3 up there is going to get used 1, 2, 3 times. So why don't we get rid of those parentheses and use it? So we're going to have -64 raised to the 2/3. Okay. Should probably make sure that that's grouped since it's a negative number. And then we're going to have x to the 9th raised to the 2/3. And then on the bottom, we're going to have y to the 2/3. Okay, so we're going to use our calculator. We're going to go and figure out, in parentheses, -64 raised to the 2/3. If you have an old calculator, make sure your 2/3 was in parentheses. And that's going to actually spit us out a nice 16. So now we can see where they get 16 from. Okay. And then here, we know that we're going to multiply those. So 9 times 2/3 in our calculator is 6. And so that would be x to the 6th. And on the bottom, that could stay y to the 2/3. However, if you look at all your choices, they're rewritten as a radical. So we'll rewrite it as a radical with y underneath. 3's on the bottom, so 3 goes in the crack. And then the 2. All right, which one is it? It's not 1, because that has a 2 in the crack, and we have a 3 in the crack. Okay? It's not choice 3, because that has a 2 in the crack. And we have a 3. And I think choice 2 matches. And we're done. All right, guys. Try your homework. A couple of those are going to give you a little bit of problems, but give it a shot. Yeah, you can always check the answer key and see my work and see how it's done. All right, guys. I will see you on the next day.